All right, guys, let's go over comparing proportional relationships. So the past few days we've been working on looking at proportional relationships and using equations and graphs to help us compare. But sometimes, or to analyze equations and proportional relationships, but sometimes you need to look at two different ones and analyze them and compare the differences between the two. When we're doing that, we are going to look for something where we can, they're represented, we're going to look for common information. So sometimes when comparing the two, we're going to see things like they're in an equation, or we get a constant of proportionality, or we get a graph, or we get a table. Well, when you get different methods like that, you need to find a common piece of information to be able to compare them. That common piece of information you're looking for is your constant of proportionality or your rate of change. Okay, remember that your constant of proportionality is always K. And remember that the formula for K is K equals Y divided by X. And if you see K or constant of proportionality in an equation, it's Y equals KX, where our rate of change or our constant of proportionality is K. So let's continue forward. And let's practice a problem here. Claire's earnings are represented by the equation Y equals 14.5x, where her earnings is Y and her hours working is X. The information here shows Jada's pay. Okay, she worked 7 hours. This is the amount she earned. Okay, so now we want to know who is paid the higher rate per hour. How much more does that person have after 20 hours? So we already know Claire's rate per hour because her K, or her rate of change or constant proportionality, is right here. It's 14.5. But we don't know Jada's. So we have to find hers by using our formula K equals Y divide X. Okay, so remember it says Y is the earnings and X is the time in hours. So if I'm going to do that, I'm going to do 92.75 divided by X, which is 7. Okay, so now I'm going to divide out 92.75 divided by 7. 7 goes into 92.75 one time, or 9 one time. 9 minus 7 is 2. Bring the 2 down. 7 goes into 22 3 times. 7 times 3 is 21. That leaves 1 left over. Bring the 7 down. Put my decimal up. 7 goes into 17 2 times. Minus 14 gives me 3. Bring the 5 down. 7 goes into 35 5 times. 7 times 5 is 35. So that tells us that Jada's K is 13.25, or her equation is Y equals 13.25. X. So who makes more money? Jada or Claire? Jada is making more money because 13.25 is, Claire is making more money because 14.5 is higher than 13.25. So now we're going to move on to the next part, and we're going to calculate who made more at 20 hours. We know that Claire makes more overall. Now we're going to find out who makes more at 20 hours. All right, in order to calculate this, what I'm going to do is I'm going to plug in the 20 for X, because that's the amount of hours that they've worked. So I'm going to do Y equals 14.5 times 20 to figure out how many hours Claire's worked. So now if I'm doing 14.5 times 20, 0 times 5 is 0. 0 times the rest is going to be 0, so I'm just going to leave my 0 there. 2 times 5 is 10. Carry the 1. 2 times 4 is 8 plus 1 is 9. 2 times 2, or 1 is 2. Now I got to put 1 decimal place in. So Claire, after working 20 hours, makes $290. So let's figure out how much Jada makes. So again, I have to plug it into her equation. So I'm going to plug it in. It's going to be Y equals 13.25 times 20. So now I have to do 13.25 times 20 to figure out how much Jada makes for 20 hours. So let's do that. 13.25 times 20. Okay, again, 0 times everything is just going to be 0, so I'm just going to leave my 0 down. 2 times 5 is 10, carry the 1. 2 times 2 is 4, plus 1 is 5. 2 times 3 is 6, and 2 times 1 is 2. I need to put 2 decimals in, so I'm going to put 2 decimals in. So Jada makes $265 in 20 hours. So if I want to know how much more Claire makes in 20 hours, I now have to do 290 minus 265. So I'm going to borrow, make that an 8. 10 minus 5 is 5. 8 minus 6 is 2. 2 minus 2 is 0. So Claire makes 25 more. So now we've completed this practice problem, so let's try another one. I'm going to clear my slide. And let's try this next one. Summer babysits her neighbor's children. Her earnings are given by the equation 8.4x, where x represents the number of hours she works, and y represents her money. Tiara earns $7 per hour mowing her lawn. Who makes more money after working 12 hours? How much more do they make? How do you know? All right. Well, we already have Summer's equation. It's y equals 8.4, so we know she makes 8.4 an hour. Then we have Tiara, who makes $7 an hour. So her equation is going to be y equals 7x. Who's going to make more money? Who can you, just looking at them, you should be able to tell. Who is it? Good, it's Summer, because Summer makes 8.4 versus 7. So now let's figure out how much they both make at 12 hours. So I'm going to do y equals 8.4 times 12. And then I'm going to do 7 times 12. Okay? So I'm going to start by doing my 8.4 times 12 over here. Okay, 2 times 4 is 8. 2 times 8 is 16. Bring my 0 down. 1 times 4 is 4. 1 times 8 is 8. Now I'm going to add that together. 8 plus 0 is 8. 6 plus 4 is 10. Carry the 1. 1 plus 1 plus 8 is 10. Carry the 1. I need one decimal place, so Summer makes $100.80 in 12 hours. Let's find out how much Tiara makes. Okay, 7 times 2 is 14. Carry the 1. 7 times 1 is 7 plus 1 is 84. So Tiara makes 84. So if I wanted to know how much more Tiara makes, then I'd do $100.80 minus 84. Okay, obviously that's going to still leave my 80 cents there, but I'm going to have to borrow. This is going to be a 9, that's a 10. 10 minus 4 is 6. 9 minus 8 is 1. So she makes $16.80 more. In 12 hours, Summer makes $16.80 more. All right, let's go on to the next problem. I'm going to erase this, but I'm going to leave my equations there because I know it's part. Yeah, I'll just erase it and we can rewrite the equations. All right, let's go on to the next problem. What does the rate of change mean for each situation? All right, in this case, the rate of change is 8.4 for Summer and 7 for Tiara, because remember, the rate of change is the same thing as the constant of proportionality, or K. So in this case, Summer's rate of change is 8.4, or $8.40, and Tiara's is 7. So what does the rate of change mean? It means the amount of money per hour they make. In this case, their rate of change is the money per hour. All right, that one was pretty easy. Let's move on to my next one. All right, how long is it going to take each person to make $150? To find that out, I'm going to have to plug in 150 into y. So 150 equals 8.4x for Tiara, or for Summer, and 150 equals 7x for Tiara. Center of my equation is my equal sign. I've got to divide by 8.4 on both sides. So I'm doing 150 divided by 8.4. So I'm going to put that here, 8.4 and 150. All right, I'm going to move my decimal over 1, which means I'm going to move my decimal 1 over here. 84 doesn't go into 1, doesn't go into 15, but it can go into 150 one time. So I'm going to subtract 84. I'm going to borrow, make that a 4, make that a 10. 10 minus 4 is 6. I'm going to borrow and make that a 14. 14 minus 8 is 6. And bring my 0 down. All right, for this next one, I've got 660. I know that 80 times 8 would give me around 64, so I'm going to go with 7. Okay? 7 times 4 is 28, carry the 2. 7 times 8 is 56, so that's 588. So now I'm going to borrow, and I'm going to make that 10. 10 minus 8 is 2. 5 minus 8 I can't do, so I'm going to borrow, make that 15. 15 minus 8 is 7. 5 minus 5 is 0. Now I'm going to bring my 0 down, and I've got 720. So I'm going to say that that's going to be around 8. 8 times 4 is 32. Carry the 3. 8 times 8 is 64. Plus 3 is going to give me 67. I'm going to leave it at 17.8. So that's 17.8 hours that Summer's going to have to work to get $150. Let's find out how much Tiara has to work. So I'm going to do 150 divided by 7. 7 goes into 15 2 times. So that's 14 minus 1 is 10. 7 goes into 10 one time. Put my decimal up, minus 7. Gives me 3. Bring my 0 down. 7 goes into 30 about 4 times. So for Tiara, she's going to have to work about 21.4 hours to make 150. All right, let's move on to the last problem. All right, so let's do our next problem. It says Mr. Bauman had 16 cups of lemonade mix. How many cups of water would he need for his recipe? Explain how you know. Well, here's his recipe. He starts a lemonade stand with his recipe. One of his recipes that he's using is y equals 4x, where x represents the amount of lemonade mix and y is the amount of water. This chart is his recipe too. So if he had 16 cups of mix, how much water would he need for each recipe? Well, for this first recipe, it's really easy because we know that 16 is the lemonade mix, which is x, and that y is the amount of water, so we just plug it in. We do y equals 4 times 16. Okay? 4 times 6 is 24. Carry the 2. 4 times 1 is 4 plus 2 is 64. So he's going to need 64 cups of water for 16 mix of lemonade for recipe A. So this is recipe A. Let's find out for recipe B. If you look at recipe B, we cannot see what the equation is. So we need to calculate it. So we're going to do that by doing k equals y divide x. Our y is 50, our x is 10. So I'm going to do 50 divide x. 50 divide 10. 50 divided by 10 is 5. Okay? So now that I have that, I can say y equals 5x. And I can plug in 16 here to figure out more. So 5 times 6 is going to be 30. Carry the 3. 5 times 1 is 5 plus 3 is 8. So he needs 80 cups of water for the other one. All right. So let's move on to the next part. Okay, so the next one says, well, what does the rate of change mean for this equation? Well, for this equation, the rate of change is the ratio between water and lemonade, or the water per lemonade mix. Think about it if we looked at it this way. K equals y over x. We know that y represents water, and x represents lemonade mix. So it's the water per lemonade mix for our rate of change. So we know that in this first recipe, you need 4 cups of water for every 1 cup of lemonade mix. In the second recipe, since it was y equals 5x, you need 5 cups of water for every 1 cup of lemonade mix. All right, let's move on to our last problem. Mr. Bauman has a 5-gallon jug which holds 80 cups to use for his lemonade stand mix and 16 cups of lemonade stand mix. Which one should he use? So if we remember, when we plugged in this, it said 4 times 16 gave us 64, right? And then our other one was 5 times 16, which gave us 80. So which recipe should he use? You're right. He's going to want to use recipe A because he's going to put in 16 cups of mix and 64 cups of water. That's going to equal 80 cups. So that's going to fill his jug. Versus this one, he would add in 80 cups of water and 16 cups, which would give him 96 total cups, which is too much for his jug. He's going to use recipe A. All right, guys, go ahead and close out of this and complete checkpoint 2 in Summit. Have a great day, guys.